This is Signal Hound's Talkin' RF, and today we're talking swept analysis mode in Spike. Swept analysis mode is the setting in Spike that allows you to sweep across frequencies that make up the span you are interested in analyzing. It's the most commonly used mode with spectrum analyzers displaying the FFT plot of the spectrum you have set in the span window.
Hello, welcome to Talking RF. I'm Tom Lane, the president of Signal Hound, and today we're going to be talking about the sweep analysis mode in Spike using the SM200C, the VSG60, and the Spike software. The swept analysis mode or sweep analysis mode is the most commonly used mode and it's what you most commonly look at and refer to when you think of spectrum analyzers. And in Spike, when you launch this Spike initially, it's going to go out and detect the device that you're connected to, the spectrum analyzer you're connected to, and it's going to determine the bandwidth or the max full span width of that device, and it's going to set the center frequency for you, and it's going to enable what we refer to as auto triggering or a continuous trigger mode. And upon boot up, it's going to show you what the RF spectrum is as seen by that device and through the span that is that device's entire span. So as you can see, the spectrum shows the noise floor, and there are a couple of points that rise above the noise floor, which are signals. Now I have a signal specifically set up on the VSG60 for this demo that's centered around 1 gigahertz. But before we get there, there's a couple of triggering modes that I want to point out. I mentioned the auto triggering mode initially, and there's another triggering mode which is the single mode, which just allows you to click the single button and it'll just trigger every time you hit the single trigger button. So I'm going to go back into auto mode, and it'll just walk you through setting up a swept analysis. So the first thing to look at is the sweep settings dialogues, and the frequency is the first thing you're going to want to look at. And you'll want to set a center frequency. I know that my center frequency is around 1 gigahertz, so I'm going to go ahead and just set that at 1 gigahertz. At 1 gigahertz, you see that the signal is now centered, and you can see that there is something there in my 1 gigahertz span. So the span is the region that we're going to sweep across, and you can set the span either by using the up-down arrows, or you can type in a span. There's a start frequency that you can set or a stop frequency that you can set, which will also calculate what the span is. There's a step size, and the step size defaults to 20 megahertz, and that's the step size for the center frequency up and down arrows. So it will step by 20 gigahertz, 20 megahertz is what I have it set for initially. I'm going to leave it at 1 gigahertz. A couple of other handy buttons here are the full span, which you can click and return to the full span of the device that you're connected to, and then zero span. We're not going to talk about zero span today. We'll talk about zero span in another demo. So we'll go back to a 1 gigahertz span and continue talking about this. Okay, so underneath the frequency settings are the amplitude settings. So the first amplitude setting is the reference level. The reference level default is at minus 20 dBm, and this reference level is going to set the top graticule line and establish what the top graticule line is. At this point, it's at minus 20 dBm. So you can change the units from dBm to dB microvolts, dB millivolts, etc. We'll just leave it at dBm for the demo. The division is the division per graticule, and we have it set at 10 dB steps, and you can change the step size. And then you see that you can adjust gain, attenuation, and the preamp for the device if the device supports that. But this is all grayed out right now, and it's grayed out because we default to auto mode. If you want to go and adjust attenuation, for example, on an SM200C, you have to go into the settings dialog box and enable manual gain and attenuation. We don't need to do that for this demo. Below the amplitude window is the bandwidth window, where we're going to set the resolution bandwidth for the device. Now, resolution bandwidth is a very key spec that we're going to set for this device. It's going to be a trade-off as you set the resolution bandwidth to the signals that you can actually resolve and the sweep time. And really what it's doing in the background, it's setting the number of points for our FFT. The swept analysis mode is the most common mode used with spectrum analyzers, and it's basically just showing you an FFT plot of the spectrum that you've set in your span and center frequency. If you have any questions, leave them in the comments below. Like, follow, and subscribe for more Signal Hound and RF content.